Hello guys, welcome back to another problem solution video. Today we'll be another question here from the COMC 2004 contest. This is the second question of part B, and as always, let's first start off by reading the question. So, determine all the real values of c such that x squared minus 4x minus c minus in square root x squared 8 times x squared minus 32x minus 8c is going to be equal to 0 has precisely two distinct real solutions for x. Now here we're going to I'll write down here, we're going to let a, so my new variable here, a, is going to be equal to x squared minus 4x minus c. And so this equation here is now going to turn into a minus square root b. So not b, 8a. Right, so I'll write this down here as well. 8 minus square root 8a is going to be equal to 0. And then we can get from this that square root 8a is going to be equal to a. And then we can also get from this that 8a is going to be equal to a squared. And so this means that, and then we can also get from this is like a very long line, a times 8 minus a. So we can say we can let a is going to be equal to x squared minus 4x minus c. We plug that into here to receive this, and then from this we can move 8a over to the other side to receive square root 8a is going to be equal to a. And then this is going to be, and then we can further square both sides so that we get 8a is going to be equal to a squared, and after that we can move them both to one side and factor it to receive a times 8 minus a is going to be equal to 0. And so this means that a is going to be equal to 0 or 8. Now let's do some case work. We know whether a is going to be equal to 0 or if a is going to be equal to 8. And now we need to solve for c. So in the first one, let's say a is going to be equal to 0. This means that x squared minus 4x minus c is going to be 0. Now we can see here that the delta for the discriminant, right, I'm going to label as delta, is going to be equal to 16 plus 4c. So this is the discriminant of the quadratic formula here. And the thing you really need to know about the discriminant is that if the discriminant is bigger than 0, this means that the equation has two solutions that are different. If the discriminant is going to be equal to 0, that means there's one solution, and if the discriminant is smaller than 0, there's going to be no solutions. So from here, we can see that, doing some casework here, if the discriminant is bigger than 0, this means that c has to be bigger than -4, and there are going to be two solutions. Then, if we have the discriminant is going to be equal to 0, which is where c is going to be equal to -4, then we only have one solution. I'm actually going to draw a little line in between so you can tell that we're talking about something different. And then finally, if the discriminant is going to be smaller than 0, not equal to, this means that c here is going to have to be smaller than -4. We have no solutions. Similarly, we do the same thing with our second part, which is going to be if a is going to be equal to 8. From here, we have the same thing. X squared minus 4x minus c minus 8 is going to be equal to 0. And then we're going to do the same thing with this, where the discriminant is going to be equal to, I believe, 16 plus 4 times c plus 8. And so, if the discriminant is bigger than 0 and c is going to be bigger than -12, we have two solutions. If the discriminant is equal to 0 and c is equal to -12, then we have one solution. And finally, if the discriminant is going to be smaller than 0, c is going to be smaller than -12. And this is where you get no solutions, or 0 solutions. Now the reason why we did this is because of the ranges here. So of the ranges of C to be specific. So if C is going to be small, it's going to be smaller than, equal to, or greater than -12, or if C is going to be smaller than, equal to, or greater than -4. Now the reason why I did this is because now I'm going to draw a small little table. So I'll draw it here where I have some space. Alright, this is a little bit confusing, but I'll just explain. So the 1 and the 2 here is for the equations, and the total is the total amount of solutions they have in total. So when you add these two possibilities both up. So if C is going to be, let's do smaller than -12, right? So I'm just not going to write C here because we don't have any space. And here, in this case, equation number 1 has 0 solutions, equation 2 also has 0 solutions, and so the total is going to be 0. If it is going to be equal to -12, then here, equation number 1 still has zero solutions, but equation number 2 has 1 solution, so the total is going to be 1. And similarly, if it's going to be bigger than -12, but smaller than -4 here, we can see that equation number 1 still has no equations, but equation number 2 has, you guessed it, 2 equations. So the total is going to be 2, and I'll mark this down because this is viable. So continuing on, we have if it's going to be equal to -4. Here we have 1 solution here, 2 solutions there, and if it's going to be bigger than -4, 2 solutions here, 2 solutions here, and so 4 solutions in total. Now here we can see that if C is in between -12 and -4, this works. So I'll write that down. In between -12 and -4. Right? But now let's look at here. What if one of the roots in equation number 1 is also going to be the same as one of the roots in equation number 2? What would happen then? So now we're going to plug in what happens if C is going to be equal to -4 into equation number 1 and solve for it. So in C squared minus 4x minus -4, if you plug in C, this would be x squared minus 4x plus 4. And this is going to be equal to x minus 2 squared, and so x would be equal to 2 in this scenario. That's why we have one equation, one solution. It's x going to be equal to 2. Now we're going to plug this into equation number 2 to make sure that the 2 solutions here and the 1 solution here don't overlap. So going back down here, we'll plug in the fact that c is going to be equal to -4. So x squared minus 4x minus 12 is going to be equal to 0. And if you plug in 2 here, we can see that this is going to be 4 minus 8 minus 12, and this is not going to be equal to 0. And hence, we know that these two solutions are going to be different from this and this, and that for these two, even if the second solution here is going to be different from the first one, it won't matter because we know that at least 3 of them aren't going to be the same, and they're going to be distinct, which means that these two we can also look cross out. So this means that the only viable range will have to be -12 to -4. I should write this a little bit prettier. -12 to -4. So that's our answer. Thank you guys for listening. If you've any other way to solve this problem, please let me know down below in the comments, and thank you guys for listening. Bye.